Hello, welcome back to the Mr. Joe Show. Just kidding, that's what this is called. So 7.4 is about measuring angles. Last time we talked about measuring segments. So some vocab, lots of vocab here, but most of it you've probably already heard of. So angle, sides of an angle, vertex, circle, measure of an angle, acute, right and obtuse angles, straight angle, and congruent angles. So looking at all of these different angles here, which ones are the same size is what it's asking. And if we look, well, they're all acute except for G. So G is not the same as any of them. But you can kind of, if you could turn them and fit them onto each other, then they're probably the same size. So it looks like C and D and E and probably F are probably all the same size, or pretty close to the same size. It's kind of hard to tell if you can actually move them or measure them. And we'll talk about how to measure angles in a second. Okay, so an angle is formed by two rays. Remember, rays have an endpoint and then extend forever in one direction. Okay, so two rays that start at the same endpoint. The rays are the sides of the angle, and the endpoint is called the vertex. Okay, so if you look at this diagram over here, we have this angle right here. A is going to be your vertex, because that's where the endpoints are. And then your two rays are AB going that way, and AC going that way. Okay, you can name an angle by, there's a couple different ways. You can name it by its vertex. Okay, if that vertex A only has one angle attached to it, then you can say this is angle A. You can pick a point on each ray and the vertex. So for example, you can say this is angle, this is the angle sign, also kind of looks like a less than sign, but you can say it's angle BAC because you're starting at B, going to A, going to C. Or you could reverse that and you could say start at C, go to A, then go to B. So you could say CAB. But your vertex has to be in the middle. Okay, or there's also, in this case, there's a number on the interior of the angle, the inside, and it's 1, so you could just call this angle 1 also. Okay, when you name angles using 3 points, the vertex must go in the middle. We talked about that. The interior of the angle is the region that contains all the points between the two sides of the angle. So the inside of the angle, basically. So the one that's in between the two rays. The exterior is everything outside of that angle. Okay. Okay. What are two other names for angle 1? Great question. Let's figure it out. So angle 1 is this angle right here. Hiya. Okay. So in this case we can't, so the M is the vertex, but we can't say angle M because M could be talking about this angle, M could be talking about our angle 1, could also be talking about angle 2. There's a lot of angles here that have the vertex of M, so we can't call this angle M. So in this case we have to use 3 points. We can call this angle JMK, because we start at J, go to M, go to K. Or we could say this is angle KMJ. KMJ. Okay, these are both the same. But notice M is always in the middle. Okay, but we cannot call this angle M because that's not specific enough. That doesn't tell us which angle that we're looking at. Okay, next. One way to measure the size of an angle is in degrees. To indicate the measure of an angle, write a lowercase m in front of the angle symbol. So in the diagram, the measure of A, angle A, is 62. So you write measure, M, that stands for measure of angle A, equals 62. So we don't say angle A equals 62 because that's talking about the actual angle. Okay, the angle can't equal a number. The measure of the angle can't equal a number. So if we're saying how big is the angle, then we can say it's 62. Okay, but we can't say that the angle equals something. So we just have to put that M in front. It's kind of like when you're saying the side length, you have to say AB equals 5, not the segment AB equals 5. Okay. So same thing with angles. When it's a measure, it has to be equal. Okay, but then we have the protractor postulate. So a circle is, you know what a circle is, it's Well, it's a set of all points in a plane that are a given distance from a point. So you have the center of the circle, and then all the distance, the circle is the same distance from the center. Okay, a circle has 360 degrees, so 1 degree is 1/360th of a circle. Okay, so if you want to get 1 degree, you just divide the circle into 360 pieces. A protractor forms a half circle, and that goes from 0 to 180 degrees, because it's a half circle. So the protractor postulate says, consider ray OB and point A on one side of OB. Every ray of the form OA can be paired 1 to 1 with a real number from 0 to 180. So basically, you can measure any angle that goes from OB and then has another angle OA, another ray. So anywhere out here you can give an angle or measure to. Okay, as long as you have one ray as your base, the OB is our base, then we can measure any other ray. And that gives us the measure of the angle. Okay, so protractor postulate allows you to find the measure of an angle. Consider the diagram below. Measure of angle COD is the absolute value of the difference of the real numbers paired with OC and OD. So if we take OC, that's about 135. If you look at the small one here, 135. So we can say this is 135 minus D crosses at, I don't know, what's that, like 33 or something? Hello, 33. So that measure would be about 102. Okay, we're just kind of estimating because I can't really tell what that is exactly. But notice I looked at both of the lower numbers here. You could also look at both of the higher numbers up here. But make sure you're doing the same thing when you're using a protractor. Both the lower ones or both the higher ones, and you're subtracting. Okay, 4 different types of angles. You have an acute angle, which is less than 90 degrees. You have a right angle, which is exactly 90 degrees, and an obtuse angle, which is bigger than 90 degrees, and less than 180. And then you have a straight angle, which is exactly 180 degrees. Okay, that little symbol in there means a right angle. Means it's 90 degrees. Okay, looking at this is what are the measures of LKN, angle LKN? So LKN, that angle right there. So it starts at 0, which is nice. So I just need to figure out where it crosses. So it crosses here and here. Obviously, this is an obtuse angle, so it's not going to be 35 degrees. So I'm actually looking at the little numbers down there. And it crosses at about 145. So we could say measure of angle LKN is 145. That's really bad handwriting. Hopefully you listened when I read that, because yeah. JKL is this angle here. So this one does not start at 0. So JKL, we need to do like a little subtraction here. So we can look at the big numbers or the small numbers. I'll look at the ones on top now because we've been doing the bottom ones before. But so that starts at 90. And we're going to subtract whatever that is, which it looks like it's at 35. 90 minus 35 gives us 55. So measure of JKL is 55. And then JKN, oh wow, sorry. Measure of angle JKN, JKN, well, it starts at 0 again because the KN goes to 90, so this is just 90 degrees. So it's a right angle. So this one's right. I didn't finish the problem. Classify it's right, acute, or straight, or obtuse. This one is acute because it's less than 90. This one is obtuse because it's bigger than 90 and less than 180. Okay, angles with the same measure are congruent angles. So this means that the measure of angle A equals the measure of angle B. If the measure of angle A equals the measure of angle B, then angle A is congruent to angle B. You can also say if angle A is congruent to angle B, then the measures are the same. You can mark angles with arcs to show that they are congruent. If there's more than one set of congruent angles, it is marked with the same number of arcs. So for example, if you look at this picture here, the top 2 angles here and here, they each have 1 arc. Okay, the bottom 2 have 2 arcs. So that tells us the bottom 2 angles are congruent and the top 2 angles are congruent. Okay, so this says synchronized swimmers form angles with their bodies if measure of angle GHJ, so that's this one, GHJ, is 90. So if that's 90 degrees, what is KLM? Well, we know those are congruent, so that tells us that the measure of angle KLM is also 90 degrees. Hooray, we did it. Okay. We have the angle addition postulate, which is similar to the segment addition postulate. It just says that if point B is in the interior of angle AOC, then the measure of angle AOB plus the measure of angle BOC is congruent or is equal to the measure of angle AOC. So basically, if you have two angles that are connected, they're sharing one ray, one side, if you put them together, they form a larger angle, AOC. Okay. So in this case, it says if the measure of angle RQT, that's a Q, T, oh whoops, T is this one, is 155, what is RQS, and the measure of angle TQS. So we know the whole angle is 55, so 155. So I can just add these two together, 4x minus 20 plus 3x plus 14, and then solve that equation. So 155 equals, we can add these to get 7x, negative 20 plus 14 is negative 6, and then simplify from there. So we can add 6 to both sides. Hello, work. So that gives us 161 equals, these cancel, 7x, divide by 7, that means x equals 161 divided by 7, I know what that is. That is 23. Okay, again, it doesn't ask for x though, it asks for what is each angle. So I need to plug it back in. So 4 times 23 minus 20 is going to be the first one. So that will be 72. So this angle right here, 72 degrees. And then we know that they add up to 155, so I can just do 155 minus 72, or I can plug in 23 to here as well. That's going to be 83. So that angle here is 83 degrees. Okay. That's the angle addition postulate. Okay, and then the last one, this says DEF is a straight angle, meaning it's 180 degrees, it's a straight line. What is DEC and CEF? Okay, so I'm going to let you try that. So you can pause this in 3, 2, 1, pause. Alright, so I got my x equals 14, so I plug it back in, and I got DEC, the measure of angle DEC is 142, measure of angle CEF is 38. And if we add those together, they do equal 180. So, looks like we did it. Hopefully we did it. I did it. Hopefully you did it. Okay, and that's all I've got. So, take the quiz, make sure you get full points on it. And yeah, thanks for watching. Remember, smash that like button. See you in the next one.